Hello there. My name is Michael Tawonga Kamanga. I'm here to teach you chemistry, that is Form 1 chemistry. And my topic today, the lesson topic is the atomic structure. So be with me throughout the presentation so that you should learn one or two things. Well, in today's lesson, uh, the success criteria is by the end of this chapter, you should be able to, one, describe an atom, then two, you state the characteristics of the particles that make an atom. You have to describe an atom and state the characteristics of the particles that make an atom. Well, we'll begin by describing what an atom is. This is very, very important because we have to know what an atom is. By definition, an atom is the basic unit of matter that defines the chemical elements. The basic unit of matter that defines the chemical elements. So in this regard, therefore, the structure of an atom is often compared to a miniature solar system, where you have the solar system and you have the nucleus, and in this case, in the solar system, the nucleus is compared to as the sun, and the electrons, the planets orbiting around it. So you know the solar system where you have the sun and the sun, from there you have the planets, and the planets are always orbiting around it. They're orbiting around, that is, the planets are orbiting around the sun. So with this view, therefore, we can liken the solar system to the structure of an atom. But however, this analogy is not entirely accurate, since electrons exist in the probability clouds rather than fixed orbits, because the electrons they do exist in the clouds, and these clouds, they're just imaginary clouds, commonly referred to as shells, shells or energy levels. We're still describing an atom. So these atoms can combine to form molecules and compounds. So being the basic unit of matter, the atoms, they are not visible by the human eye. So they can be assembled, they can be combined to form molecules and compounds. So they do participate in chemical reactions to create the vast array of substances that make up the universe. So once they combine, then they will always take part in chemical reactions to create the vast array of substances that make up the universe. In fact, all the substances which you see around, they are made up of these atoms, whether molecules and compounds. So each element, atoms have unique properties due to the different numbers and arrangement of protons, neutrons, and electrons. In other words, each element, this is like a DNA of an element, because you cannot compare DNAs of maybe, let's say, 2 or 3 people. The DNA of an individual is always unique. So this can also be explained in line of an atom, of an element rather, because elements, remember atoms, once they're combined, they're the ones which make up an element. So each element has its own number of protons, number of neutrons, and number of electrons. So these electrons, protons, and neutrons, they are known as the subatomic particles. They're known as subatomic particles. So at its core, an atom consists of three main types of subatomic particles. As I've already said, these subatomic particles, they are protons, neutrons, and electrons. So these are known as the subatomic particles. Now, a brief description of these subatomic particles. Protons, these they are positively charged particles, and they reside in the atom's nucleus, and they define the atomic number. So this atomic number, in other lessons, I'll explain more about the atomic number because it is one of the characteristics of an atom. So the atomic number is determined by the positively charged particles known as protons. So these protons, or the atomic number rather, they act as an identity of an atom. Then secondary, we have neutrons as another subatomic particle. These they are neutral particles in nature, and they are also found in the nucleus alongside the protons. They're found inside the nucleus alongside the protons. So neutrons, they do contribute to the atomic mass. How an atom weighs, how an element weighs, this is mostly it is contributed by the neutrons, because the neutrons, they do affect the atomic mass, which is another characteristic of an atom. The atomic mass of an atom, but they do not affect the atomic number. So here, the atomic number is only affected by the number of protons, or by the protons, while the atomic mass is only affected by the neutrons and not the protons. Then lastly, the last subatomic particle is an electron. So these electrons, they carry a negative charge. They have a negative charge. If we go back to the protons, they are positively charged. So they have a positive charge, while the electrons, they have a negative charge. And remember that the protons, they are found inside the nucleus, while electrons, they are not found inside the nucleus. Instead, the electrons, they are found outside of the nucleus in orbits. So the electrons, the negatively charged particles, they orbit, or they revolve around the nucleus in regions known as electron shells or clouds, or energy levels. So electrons are involved in chemical bonding and reactions. So remember, protons, they are involved in atomic number. Neutrons, they are involved in atomic mass. But electrons, they are the ones which do take part in the chemical bonding and reactions. So all the reactions, the reactions, uh, it is only the electrons which take part in these chemical reactions and in bonding, in bond formation. Now, let us go in details on the characteristics of these subatomic particles. We'll begin by looking at a proton. And remember, a proton is a subatomic particle which is found in the nucleus of an atom. It is a subatomic particle found in the nucleus of an atom. So here are some of the key characteristics of these protons. We'll begin by looking at the charge. You may recall that a proton, it has a positive electric charge, which is denoted as a positive 1. Positive because a proton is positive in nature. So you can denote a proton by writing positive 1. Furthermore, the same proton, this positive charge is equal in magnitude but opposite to the charge of an electron. So yes, an electron and a proton, in terms of magnitude, in terms of size, they're the same. They only differ on the charge, because a proton, it has a positive charge. Please take note of that, because this is very, very important. On the same proton, we are going to look at the mass of a proton. So protons are relatively heavy compared to electrons. They are relatively heavy. And in fact, the mass of a proton is approximately 1 atomic mass unit, or 1.67 times 10 to the power minus 27 kilograms, which is about 1,836 times the mass of an electron. So you can see that a proton, when compared to an electron, a proton is indeed heavy. That is 1,836 times the mass of an electron. The role in atoms of protons, the number of protons in the nucleus of an atom determines the atomic number. And this atomic number is the identity of an element. So you can always know an element using the atomic number, its atomic number. For example, all hydrogen atoms have 1 proton, and all carbon atoms have 6 protons. So as you can see, the identity of hydrogen atom is that it has 1 proton, and the identity of a carbon is that carbon has 6 protons. In terms of stability, protons are stable particles within the nucleus, and they play a crucial role in the structure and stability of the atom. Structure and ability of the atom. They along with the neutrons, they contribute to the majority of an atom's mass. Why? Because a proton, remember, it is heavy. So because of its heaviness, it will always contribute to the mass of an atom. What about an electron? The key characteristics of an electron, electrons include charge. Electrons have a negative electrical charge, denoted as -1. Remember, for the protons, it is positively charged, denoted +1. But for the electron, it is denoted -1. So this charge is equal in magnitude but opposite to the positive charge of a proton. So in terms of size, in terms of magnitude, an electron is always equal. But the main difference is that a proton is positively charged while an electron is negatively charged. Bear that in mind. In terms of mass, electrons are much lighter than protons. They are much lighter. They are much lighter than protons and neutrons. They are much lighter than protons and neutrons. In fact, the mass of an electron is approximately 9.11 times 10 to the power minus 31 kilograms. 9.11 times 10 to the power minus 31 kilograms, or about 1 over 1,836,000 mass of a proton. So you can imagine an electron is relatively lighter. It's very lighter. And in terms of location, an electron is found in regions around the nucleus of an atom. And these regions are called electron shells or orbitals. So these regions, they do represent areas of high probability, areas of high chance where you are likely to find an electron. So they're not fixed as such, they're not fixed, but they're just regions of high probability where you are likely to find these electrons. In terms of behavior and energy levels, electrons can occupy different energy levels with an atom. It will depend on the energy of that particular energy level. So they can absorb or release energy by moving between these levels, which is fundamental aspect of how atoms interact and bond with each other. How atoms interact and bond with each other. Role in chemical reactions. Remember, the electrons, they do take part in chemical reactions. So electrons are primarily responsible for the chemical properties of an atom. They participate in the formation of chemical bonds. We have different types of bonds. In other lessons, you see which are these types of bonds. So the electrons, the ones which are responsible in a bond formation. So chemical bonds include covalent and ionic bonds are involved in the conduction of electricity. And the electrons are integral to the structure of atoms and their interactions with other atoms, making them essential to the formation of molecules and the chemistry that underlies all matter. So in summary, these electrons are the ones which take part in chemical reactions. All the chemical reactions which do take place, the electrons are involved. Now let us go to a neutron. So a neutron is a subatomic particle, and this is the third and last subatomic particle. That is a very essential component of atomic nuclei. So its key characteristics, beginning with charge, is that these neutrons are electrically neutral, meaning they have no net charge. Can you recall the charges of a proton and an electron? I believe for the proton, you have said +1, and for the electron, you have said -1. While for these neutrons, they don't have a net charge. And other literature says they have a 0 charge. So this neutrality distinguishes them from protons, which are positively charged, and electrons, which are negatively charged. In terms of mass, neutrons have a mass slightly greater than that of protons, just slightly greater. So if we are to arrange them in order, the one which is heavier is the proton, rather a neutron, then followed by protons, then lastly we have electrons. So neutrons have a mass slightly greater than that of protons. In fact, the mass of the neutron is approximately 1.675 times 10 to the power minus 27 kilograms, which is about 1 atomic mass unit. AMU, abbreviated AMU, because AMU stands for atomic mass unit. Then, in terms of compositions, neutrons are composed of 3 quarks, which is 1 up quark and 2 down quarks held together by strong nuclear force mediated by gluons. Then, in terms of location in the atom, neutrons are found in the nucleus of an atom. Along with protons, the nucleus is the dense central core of the atom. So in terms of location, the neutrons are found in the nucleus of an atom. Which other subatomic particle is found in the nucleus of an atom? Yes, the answer is protons. Protons, they are also found in the nucleus of an atom. And neutrons are also found in the nucleus of the atom. Role in the nucleus, since they're found in the nucleus, the neutrons, they do help to stabilize the nucleus by offsetting the electrostatic repulsion between protons which have like charges. So they do play a critical role in the stability of atoms, particularly in elements heavier than hydrogen. Now, these neutrons, they also contribute to the concept of isotopes. So the number of neutrons in an atom, in an atom's nucleus can vary, resulting in the different isotopes of an element. So the same element, but having different number of neutrons. So isotopes rather, they have the same number of protons but different numbers of neutrons, leading to variations in atomic mass and sometimes different nuclear properties. Remember, the neutrons, they contribute to the atomic mass of an atom. So if we have elements having different number of neutrons, obviously the mass number will also change. So the isotopes, by definition, they have the same number of protons, but they differ in the number of neutrons. On the nuclear reactions, the neutrons are key players in nuclear reactions, including fission and fusion, which is mostly covered in physics. In nuclear fusion, a neutron can initiate the splitting of a heavier nucleus, which in turn releases energy. In nuclear fusion, neutrons are part of the reactions that power stars. Neutrons are crucial for understanding the atomic structure, nuclear physics, and the stability on different elements. So on this section, on nuclear fission and nuclear fusion, this is a part of nuclear physics. Now we can have a summary of an atomic structure. So as you can see there on this diagram, we have protons which have a positive charge, as you can see. So this is our nucleus, and inside of the nucleus we have protons which have a positive charge, and also we have neutrons as you can see. So in here we have 3 protons and we have 3 neutrons. Then outside of the nucleus, we have electron orbits or shells or energy levels. So remember, in terms of location, the electrons are found they are found in the electron orbits, as you can see. So in the first orbit, we have 2 electrons. In the second orbit, we have a total of 1, 2, 3, 4, 5 electrons. So in summary, this is how the atomic structure looks. And we can also have a summary of characteristics of subatomic particles. So in this table, we have particle, symbol, mass, which is in kilograms, relative mass, which is proton equal to 1, then a relative charge. Now, for proton, the symbol is P positive. Remember, for a proton, its symbol it is P, then positive. Then the mass in a kilogram of a proton, it is 1.673 times 10 to the power minus 27. Its relative mass is 1, while the relative charge is positive 1. For a neutron, it is N with a 0 on top. Remember, because the neutrons, they have they have a 0 charge, they're neutral. And the mass of a neutron is 1.675 times 10 to the power minus 27 kilograms, and its relative mass is 1, while the relative charge is 0. Then lastly, for an electron, the symbol is E negative, and the mass is 9.109 times 10 to the power minus 31 kilograms, and then the relative mass is 0.00055, and it has a relative charge of -1. Okay, now that we have looked at the atomic structure, the subatomic particles, the 3 subatomic particles, the characteristics, the key characteristics of these subatomic particles, let us look at the following activity. So this activity will help you to uh, to evaluate yourself, as in whether you have understood the subatomic particles, the 3 subatomic particles, and the characteristics of subatomic particles. Now, the first question is which of the following is true about electrons? A, they are found in the nucleus of an atom. B, they have a positive charge. C, they are heavier than protons. D, they occupy orbitals around the nucleus. Question 2, which subatomic particle has a positive charge? A, electron, B, neutron, C, proton, D, photon. Question 3, which particles are found in the nucleus of an atom? Is it A, protons and electrons, B, electrons and neutrons, C, protons and neutrons, or D, neutrons and photons? Question 4, what determines the atomic number of an element? Is it A, the number of neutrons in the nucleus, or B, the number of protons in the nucleus, or the number of electrons in the atom, or the sum of protons and neutrons in the nucleus? Okay, on the activity, you can drop your answers in the comment section so that you should compare with my answers, which will be provided to you. For any questions, you can use the numbers, that is the WhatsApp and even the email. Thank you for listening. See you in the next lesson.